This is an original Nitecore Tube. This is a clone of the Nitecore Tube, and this is the cheapest clone of the Nitecore Tube, and it cost £2.33, and it came from a seller called Snowy Summer 2012. And the distinctive characteristic of these is that they don't have the translucent or transparent cases. It's a fairly opaque case. And rather bizarrely, on the back of this, it shows quite reason enough. It shows someone pointing a beam of light at a pair of shoes, but then it shows the ultraviolet marking on a note being shown when this doesn't have any ultraviolet functionality. And then this, I'm not sure that is. Any suggestions? I think it looks like a pet jellyfish. I'm not sure, because you can see its rabid, staring eyes. But anyway, let's investigate this. And I've already run it flat and then charged it fully, and I'm afraid that the battery capacity is super low. I'm just going to nudge in here because we are going to be taking this to bits, and I know this upsets some of the people with bigger screens because they don't want it to go too big, but I'll just compromise and I'll go to a sort of middle-sized position. So I've tested this, and it's very hard to tell what the capacity of the lithium cell inside is because it's so low that the red and green charging indicators seem to skew the result a bit because they're drawing about 10, 15 milliamps. And when you consider that the capacity of the cell itself is 20 milliamps, it's a bit indecisive because it starts off, it charges at a modestly high current and then instantly falls, just like that characteristic you get when the little lithium cells are being charged far too fast. And well, the closest I could really guess to it was 20 milliamp hour. So the original, 70 milliamp hour, this clone, 35 milliamp hour, and this one, 20 milliamp hour. Modes. This one has 3 modes. You click it, it goes to full brightness. Click it again, it goes to reduced brightness. Click it again, it goes off. Hold it in, and it does, I was going to say it does SOS, but in reality it does ... dash, and then it just keeps doing that. So it's actually saying so in Morse code. But I suppose that has the desired effect. I think we should just open this. That's the best thing to do, and see what's inside. Oh, another thing, the case. The case looks identical. The only way you can really tell, I'm sure that someone will just clone it completely at some point, but the Nitecore Tube has Nitecore embossed on this side and Tube embossed on this side. This clone has got nothing embossed in it. I thought it had Tube, actually. And this one has nothing either. So the only common marking they've got on them is, well, apart from the style of the whole case, is the embossed symbol for the CE logo and the sort of don't stick it in your wheelie bin logo. These ones both have 2 clips for the lanyard to hook onto. This one has position for 2, but they've only used 1. It really is quite cheap that way, maybe for ease of manufacturing, and it's got this crimped on elastic, a bit of elastic onto that. So let's open it up, and we'll see just how big this cell is inside, and we'll see what the circuitry is like. If you recall in the previous teardown of this clone, the Nitecore itself had really quite complex circuitry. It was quite impressive. This clone had much simpler circuitry. It was, in a way, I preferred the circuitry in this clone. It would be nice to actually have the functionality of the full Nitecore, but the circuitry of that one, because it was a very uncluttered PCB. But it seems to be a characteristic trait of the Nitecore lights that they are kind of well engineered. This one does not have much in its circuit board at all. It also has a tiny little lithium cell just floating about in there. Other things I'm immediately noticing, well, apart from the fact, is that switch supposed to be skewed at that angle? Look at the angle that switch is at. Hold on, I'm going to zoom in right up so you can actually see this. That switch is not supposed to be at that angle. It's really not on its pads. I don't think it really matters, it still works. On the back, we've got 2 6-pin chips. We've got a little transistor to drive the LED, presumably, and a couple of LEDs, capacitor, resistor. I'll analyse this and see what they are. The LED is not one of the high current ones, so I'm not sure what current these are operating at. You know what? I wonder if I could get the clamp meter, the DC clamp meter through there. One moment. Right, so let's zoom out for this. I'm going to try and get the clamp meter. You're really supposed to have it fairly centered in the leads, but we'll see how this goes. And I'll turn it to that range. I shall select DC current and then 0 out, and then click the button. Ooh, 90 milliamps. That's quite a lot. 90 milliamps is full current, and then it steps down to about 35 milliamps at its reduced current. Okay. I have to say, when you, even at full power, this thing is, I don't know if you're going to see this, it's pulse width modulating. Yes, you can see that. And likewise, when you put the reduced one, you'd expect it does pulse width modulate too. The frequencies is quite odd. The Nitecore, the original Nitecore, is the highest pulse width modulation frequency. This actually comes second. It's about half the speed of that, and then this clone here has really quite appalling pulse width modulation. It's very stroby, and it's about half that clone. I just can't go over the size of this little lithium pack. I'm also noticing that there's no protective circuitry. These two have the protection circuit board on the lithium cell. This one does not. So that must be covered by one of these little chips. Right, okay, I'm going to analyse this. I'll be back in a moment. Ooh, this is a quirky little thing. First of all, a slight design flaw. It appears to be that they've got a recess for the LED to sit into. And it's squint. Well, the LEDs squint because the recess doesn't line up with the two pads. And it means that when they try putting the LED in, it goes in at an angle. And it really does. It is at a distinct angle. The button is also at an angle, and I don't know if that's deliberate, because it lines up perfectly with the centre of this cover, and that may suggest that the button has been deliberately skewed up to try and line it up. Then it's all down to pairs. There's a pair of capacitors, there's a pair of resistors, there's a pair of LEDs, there's a pair of chips, and even the leads on the micro USB connector are paired, which they kind of, I suppose there's nothing really wrong with that, but instead of just connecting the two outer leads, the positive and negative, they've actually connected on one side, they've got one of the power leads connected, just bridged across onto one of the data leads, and on the other side they've got the power connector bridged across onto an extra pin that's, I think it's for identification purposes. I don't see any harm in that, I don't think. I guess they've just done it for extra strength and ease of soldering. The two capacitors, the first capacitor here is just across the USB input for stability of the supply for the charging circuitry, and there's also a capacitor across the battery terminals. There's a sort of link that jumps across from one side to the other here. The two LEDs are fed by one of the two resistors. They're both 1K resistors, 102, 10 and 2 zeros. So that resistor limits the current through the two LEDs, and then they're switched by this charge control chip, which is a 2DLF. Not quite sure what that is. Interestingly, when you plug it into charge, it may be because of the fact that the charge current, which is about 80 milliamps-ish, was maybe too high for this tiny little cell, because that actually oscillates between the red and green LEDs. It starts off red, and then it spends a lot of time jittering between them, and if you actually swipe the circuit board, you can see it is physically stepping backwards and forwards between them. The other 1K resistor here presumably sets that current. And that just leaves this transistor, which is a PNP transistor, it's a Y2, and this erroneous chip that controls all the sort of, well, it's the button input and the LED it basically controls. The CO400, I'm guessing, CO400? I'm guessing it's a little microcontroller type thing, or an LED controller for flashlights. So it's got a power, it's the positive rail comes down here, it goes underneath the PNP transistor into the emitter, and then goes down to the chip. The negative rail comes from the battery pack here to the chip. And to turn the LED on, the negative of the LED is connected to the main sort of negative rail. And the positive is switched from the collector down to the emitter, because keep in mind this is a PNP transistor. And of course the base is just driven directly from that control chip, and that really just about sums it up. So it's a very weird, it's a reasonable enough circuit. No significant real current limiting, it's relying on the transistor for the current limiting, which is a bit weird. And that's about it. It almost looks like a prototype that, you know, went into manufacture. There are just a few oddities about it that nothing quite lined up. But I suppose it works. Maybe that's why they just sort of sold it off cheap, put a tiny little battery in it just to basically finish the product and get rid of them or something like that. It's very odd. But the main thing here is if you really want a Nitecore Tube, the actual original Nitecore Tube is such a good quality little light that I would say go for the original Nitecore Tube, because these copies, they work, they look the part, but they really don't perform anywhere near as well. And you're just going to get much more functional use out of the original product. But it was interesting to take apart anyway.